Okay, hello everyone. So today let's solve LeetCode problem 2492. Let's read the problem first. You're given a positive integer n representing n cities numbered from 1 to n. You're also given a 2D array roads where the road connects the two cities A and B. Okay. And then D is the distance. Distance. Uh, the city's graph is not necessarily connected. The score of a path between two cities is defined as the minimum distance of a road and its path. Oh, it can be any minimum distance of a road and its path is the score. Okay. Minimum possible score of a path between cities 1 and n. Okay, so if 1 and 3, the minimum distance between that is any edge which connects these two nodes, right? Okay. So essentially, each component should have a minimum score. So every component has a score. I want to solve this using union find to demonstrate it. So let's say we have two graphs, right? So let's say we have this. Uh, let's say we have a graph which is not connected, and one more like this. So this component will have one score, and this component will have another score. So let's say 3 is the smallest edge here, and then 4 is the smallest edge here. The score of this will be 4, and the score of this will be 3, right? Now if they're not connected, what do we return? Okay, they're always connected. Perfect. Okay, so what we can do is I'll do it in like classic union find fashion. So I'll create a class called union find. Okay, now define. So let's give it the number of nodes. And then let's also give it edges. Um, okay, let's also give it edges. Now each component should also have the best path associated with it. Uh, so for that, self dot best is equal to, okay, for x comma y. So edges we have the weight as well. um, Perfect. Now let's define our union find function first. Find of x if self dot parent. I'll make it singular. Parent of x is equal to x. Return x else parent of x is equal to, and okay, and then we return parent of x. Forgot the self here. Perfect. Now our union function, so if root x is equal to root y, that means they're already connected. Uh, so we just return false. If not, if root x is lesser than root y, that means we change the parent of root x. Okay, that's perfect. So we have our union function and all that, and now uh, let's do this part now. So let's say bests is equal to, okay, so return the minimum possible difference. Okay, we don't need this. It's only for 1 and n. At least one path between 1 and n. Okay. So for okay, let's create an object of union find. Perfect. And now result is equal to float of infinity. So um for all the nodes x comma y comma okay. Okay, so now we have to iterate through all the nodes again. So x comma y comma underscore the roads. So if okay, so root so if uh uf dot find of x is equal to uf dot find of y, and uf dot find of x is equal to 1, then result is equal to minimum of result comma b. Then we just have to return result. So let's see if this works. Self is not defining values. Okay, I have to pass in self everywhere. N comma roads. Do I need roads? I don't need roads, do I? Okay, why am I returning null? I'm never going there. So there's some small mistake here. Let's figure that out. Okay, the union thing is working, I guess. Okay, so the parent of 1 is 4. If root of x is lesser than, okay, it should be the other way around, right? I messed up the precedence. Yeah, and now hopefully that should be fine. So this is just a classic union find solution, and it's also, I think it's pretty efficient too. Okay, so what are we doing here? Essentially, first we're creating a union find object. Now it has two functions, which is find and union. So here um, connecting, we're iterating through all the edges, and let's say we have 1 and 3. These two are the cities. And initially, the parent of 1 is 1, parent of 3 is 3. So when we unify these two using our union function, we're checking the root of 1, which is initially 1, and the root of 3, which is initially 3, and whichever has the lesser value will be the new root. So the root of 3 will be changed to 1. And that is how you join all the nodes together using union. And in the end, I'm just iterating through all of them once and finding out the shortest path. Yeah, I hope you all understood. If you have any doubts, leave them in the comment section below. Thank you for watching.